Hi everyone, today we'll start module 5 and the first topic is input device. First let's see what is interaction. Interaction in computer graphics is how the application program communicates with the input and output device. There are two types of input device, physical input device and logical input device. Physical input device will have hardware architecture. There are two categories of physical input device, keyboard device and pointing device. Right, let's discuss some physical input device. The first one is keyboard. This is a general keyboard with set of keys, and each key in the keyboard is associated with an ASCII character. When I press a key in the keyboard, the corresponding ASCII value is returned to the user program. This is how this keyboard communicates with the application program. Next is mouse and trackball. Mouse and trackball are pointing device. Right, the motion of the ball inside the mouse is converted into signal and it is given to the computer by a pair of encoders inside this input device. These encoders calculate the motion into orthogonal direction. That's how I'll get the corresponding x and y value of the cursor. This mouse and trackball is known as relative positioning device because when I move the mouse, there will be corresponding change in the cursor location. Next is data tablet. Data tablet, here the position of the stylus is calculated by the, here we'll have rows and columns of wire under the surface, and the position of the stylus is calculated by the electromagnetic interactions between the signals across the wire. Right, and this data tablet is an absolute positioning device. And next is light pen. Inside this light pen, I'll have a light sensing device, and when I hold this light pen across this monitor and CRT monitor, you know when electron beam falls on the phosphorus coating, it starts emitting light, and when this light exceeds the threshold, right, the position of the pen is given to the computer. The position of the pen is calculated and it is given to the computer. The only disadvantage with this light pen is it cannot calculate the position in dark region. Next is joystick. Joystick, again, it calculates the motion into orthogonal direction. It gives the position in the screen. Right, and the main use of joystick, it is in simulators. And next is spaceball. Right, spaceball, it is a 3D input device. It looks like joystick, but it has a ball on its top, and I cannot move the stick until I apply some pressure in this ball, because inside this ball I have a pressure sensors, and when I apply pressures I can move the stick, and I can move the stick in all directions, that is in 3 directions: top, bottom, front, back, and left and right, and I can twist in 3 directions. These are some physical input devices. Next we can see logical input device. You take any program, that I'll take a simple C program. If I want to calculate the sum of two numbers, what is the first step I'll do is like I'll initialize all the variables, then I'll read the two values from the user using this scanf function, and I'll calculate it and I'll display the sum through the printf function. And this scanf is a logic. This scanf and printf are logical functions because they are getting the input from the user through the input devices. Even though these are logical devices, they are not aware of the physical structures of the input devices. Right? And these are known as logical input devices. We can see few more logical input device. The first one is string, and the corresponding physical device will be keyboard, and what will be returned to the program, user program, is the ASCII value of the key pressed. Next is locator. The corresponding physical device is pointing device. It can be mouse or it can be trackball, right? And what will be returned to the user program? The corresponding position of the cursor, right? Next is pick. Pick again here the physical device is pointing device, and what will be returned to the user program will be the identifier of the object, identifier of the picked object. Choice represents a choice from a selection of multiple inputs. Next is valuators. Valuators will give you the analog input. And the last one is stroke. Stroke is array of locations. Locator will give you single cursor location, and stroke will give you array of input locations. Next, we'll discuss few input modes, right? And while learning the input modes, two terms we have to remember: measure and trigger. What do you mean by measure is what is returned to the user program. What is returned to the user program will be measure. And what is trigger is physical input on the device is trigger. I'll say an example. As we discussed, if I take a keyboard and if I press any key, I told the corresponding ASCII value of the key will be returned to the user program, right? So what is returned to the user program? ASCII value of the key pressed. So that is measure. And what is trigger? I am pressing the key. I am giving some physical input to my device. What input I am giving? I am pressing the key. That is my trigger. So two things you have to remember: measure and trigger. What is returned to the user program is measure, and the physical input on the device is my trigger. And we are having three input modes. The first is request mode, right? In request mode, right, measure won't be returned to the user program until it is triggered. I repeat, measure won't be returned to the user program until it is triggered. I'll take a simple example. Right, I'll take a C program. If I take a C program to add two numbers, so I have to read both the inputs. Then only I can calculate the sum. So first I'll give enter the value of A, and I can enter the value any number I can enter, and this is the measure that has to be returned to the user program. So I have to press enter. Until then, this input, it will not be given to the user program. It waits for a trigger. So request mode is measure won't be returned to the user program until it is triggered. So once I press enter, the input will be returned to the user program. That is request mode. Right. So I'll get a trigger, then only measure will be returned to the user program. This is request mode. Next is sample mode. Sample mode is immediate mode. Right, I'll take a simple example like function call. Right, you know what is function call? Function definition. When there is a function call, immediately the control goes to the function definition. Right, so that is my sample mode. There is no need of trigger. No trigger is required. Once the control sees the function call, immediately it moves to the corresponding function definition without any trigger. That is my sample mode. Sample mode, no trigger. Next is event mode. In event mode, if I have more than one input device, I can go for this event mode, right? When I have more than one input device, right? When each input device is triggered, the corresponding measure will be stored in the queue. You know the operation of queue, first in, first out, right? So all the measures, it will be first it will be placed inside the queue, then from queue one by one it will be processed. That is my event mode. And next we can discuss this client-server architecture in graphics. You all know what is client and server. Client requests some service and server does the service, right? So here this various graphic server like file server, print server, it will be distributed across the network. So if the client needs any service, it can request the server and it will be serviced by the server. So I have a print server. If I need printing in a fast rate, I can request this. Similarly, if I want to transfer huge files, I can use this file server.